Hello friends, and welcome to this screencast in which we are going to see how to find out the present value of an annuity. And for that, first of all, let us write down our formula. On the left hand side we write PVA, that is present value of the annuity. In the subscript we write a 0, and then on the right hand side we write our payment amount and multiply this by the interest factor, the basic mathematical form of which is going to be this one here. I wrote it down already here for you, this one, so let me copy and paste it here. So this becomes your formula for present value of an annuity. Look at the present value interest factor for a moment and you will realize that it is the exact opposite of the future value interest factor of the annuity. The formula for future value interest factor of the annuity, let me write it here for you so that you can compare the two. Then I'm going to erase it later. Future value interest factor of the annuity was equal to this. It was 1 plus k to the power of n, and after that we had a minus 1, and we closed the square bracket and divided this thing by the interest rate k. Now observe the differences. Rather than having a minus 1 here, we are having a plus 1 in the beginning, and this one in the future value interest factor of the annuity, this part you will recognize this as the future value interest factor of $1 alone. And here in this formula, this part here is the present value interest factor of $1, and we are dividing both of these things by the interest rate k. So basically, if I had to rewrite this thing here, I would have written it like this: 1 minus the PVIF, and I would have closed the bracket and divided this thing by k. And if I was talking about the future value interest factor of the annuity, I could have written it like this. I could have written it like the future value interest factor of $1 minus 1, and I would have closed the bracket and divided this by k. Now this future value interest factor in this case is this item here, and the present value interest factor in this case is this item here. So once this distinction is clear, now let me take out the future value interest factor of the annuity, because we are not talking about that in this screencast. So what we have with us now is the present value of an annuity formula, and therefore if we want to rewrite this formula in terms of the present value interest factor of an annuity, we can simply say payment times this item here, PVIFA, at k% interest rate for n time periods. Now let us quickly take an example to see how this formula can be put to use. Suppose you can afford to pay $12,000 per month, so it's an annuity for 3 years for buying a new car, and the bank is offering you a loan at the rate of 1.5% per month. Be careful about this, and this loan has a term of 36 months. The question is, how much can you borrow today? So if we are required to find out the amount for today, we know that we are going to be solving for the present value. Now the next question that we should ask ourselves is, are we finding out the present value of a mixed stream, or are we finding out the present value of a single amount, or are we finding out the present value of the annuity? The answer to that question lies in the examination of your data. You are going to be paying $12,000 per month, and when you do that, you know that it's going to be an annuity. So therefore we are going to be solving for the present value of the annuity in this case, for which this $12,000 becomes our payment, this 36 months becomes our time, and the interest rate k is this 1.5%. Now in this case you can't use the time value tables, because you are going to get no factor for 1.5% and also for 36 months. So we are going to take it from the grassroots, from the first principles. We are going to have to use this formula here. So let us start doing that. We have to find out the present value of the annuity, and let us start filling in the numbers into our formula. What we do is we write down the amount of payment, 12,000, and then we are going to multiply this by the present value interest factor of the annuity for 1.5% and 36 periods. Since time value tables are not going to help us in this case, we pick up the mathematical formulation of the interest factor, which is going to be 1 minus, and then we need to write the present value interest factor of $1, which we know is equal to 1 over 1 plus k. So let me write down 1 plus k here. The k is 1.5%, or in other words 0.015. So 0.015 plus 1 is going to become 1.015. So I'm writing it directly here, and then I'm going to raise this thing to the power of time periods, which in this case is 36 time periods. And then I close the bracket and divide the entire thing by my interest rate, which is 0.015. Now let us solve it. We write again 12,000, and let us solve the quantity inside the bracket. 1 minus. Now let us do something about this term here. On your financial calculators or on your scientific calculators, this is going to be pretty easy, but I'm going to have to spend some time on the desktop calculator because it is not that user friendly. So what I'm going to do is to first of all find out the value of 1.015 to the power of 36. Let me put this thing in bracket and write it like this so that it is easier to understand. Now let me do this thing 1.015, and let me raise this thing to the power of 36, and what I get is 1.7091. so let me write it here because I don't want to forget it later. So let me complete this. 1 minus 1 over, let me write down what I found for 1.015 to the power of 36. I had found out 1.7091, and let me then close this bracket and divide the whole thing by 0.015. Now again 12,000 times inside the bracket 1 minus. Now let me find out what is the value of this item here. 1 over 1.7091. Let us do that. 1 over 1.7091 gives me 0.5851. So let me just write that here. 0.5851, and then I close the bracket and divide the whole thing by 0.015. After that is equal to again 12,000 times 1 minus 0.5851. Let us write down the value of this. Let us go back to the calculator again. 1 minus 0.5851 is equal to 0.4149. So that is what I write here, 0.4149, and then I divide this guy by 0.015, and then from here it is simple. 12,000 times the division between these two items. So let us divide them and write the result here. 0.4149 divided by 0.015, and that gives me 27.66. So let me write that here, 27.66, and then it is simply a product between 12,000 and 27.66. So I multiply this 27.66 with 12,000, and this is what I get, $331,920.